Take a heavy cylinder, such as this, and place it in the river, and then turn on the water, you see the flow rolls the cylinder downstream. If I now place the same cylinder in the magnetic river and turn on the magnetic water, it rolls upstream because you see the river is flowing that way. It doesn't matter whether I use a small cylinder or a long cylinder, and these are all of copper, or whether I use a steel cylinder, they all roll backwards. A steel ball rolls the same way. So does a steel washer. Of course, you can have a lot of fun with this. This all-plastic motor car has had 4 steel wheels fitted. There's the engine. And when you release it, it goes quite nicely. Now, why is this? Why do all these pieces of metal roll backwards along the field? To understand what's going on, we need to look at the shape of the field lines over this motor. They come from a north pole into a south, like that, and the whole field pattern is moving along, like the magnetic river. Now, suppose we could sit at one place over the machine, such as in that little square, and watch the field lines go by. Notice the direction of the arrows. At the moment, the field is to the left. Now it's upwards, to the right, downwards. Left, up, right, down. So it's left, up, right, down. And the rotation, you see, is clockwise, which is to say, rolling backwards. So the whole machine behaves like a mechanical rack and pinion, in which this is the field and this is the rotor. And here is the action. Well, of course, mechanical things are easy to understand. But when we make it magnetic, it's a little less obvious. But we put in a row of horseshoe magnets, and the action, as you see, is very similar indeed. This, then, we call a rack and pinion motor.